You ready? It's been a while since we've run into my favorite student, good old Anne. And as usual, I'll do the whole question and then I'll tell you the marked breakdown. So a spaceship travels at 0.99 C for 8 years of ship time. How much time will pass on Earth? So I'm going to say, okay, this question wants me to find that. That means T0 is 8. V is 0.99 C. As an equation, I'm going to have T equals T0 over, now remember last day I said if you really wanted to be clever you could write it as a little gamma symbol, but I'll write out the whole equation. It's going to be the square root of 1 minus V over C all squared. It's going to be 8 divided by the square root of 1 minus 0.99 C all over C squared. Yay, the C's cancel. And we are at the stage where this math I can't really do in my head. Let's see what we get. I wonder if I can do this in one step. 8 divided by square root bracket 1 minus 0.99 squared close bracket. I guess. Is it 56.7 years? Woohoo! I'd take 57 years. I didn't really say what to round off to in this case or anything like that. So if you got the right answer, 2 out of 2. Otherwise, I would give you half mark for this, 1 whole mark for getting the numbers right, because I think that's the tricky part. In particular, Lindsay, it's do you know the difference between T and T0? And then a half mark for the answer. A spaceship travels at 0.96 C for 12 years ship time. How much time will pass on Earth? I'm going to argue that actually this is exactly the same question. I'm going to go copy. I think I'm going to go copy. Yep. I'm going to go paste. Except in this case, that's going to change, 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 and that's going to change. But I think the rest is going to be the same. I think we're being asked to find T0 is 12. This time we're traveling a little slower, so the time difference should be a little less significant. It's going to be 12. It's going to be 0.96. In fact, if I'm really, 12 divided by square root bracket 1 minus 0.96 squared. You get 42 I guess technically 42.9. Yes, but 42.86. I'm going to go 42.9. If you said 43 years, I'm good. If you said 42.8 years, I'm taking a half mark off, and I'm saying, learn to round off properly for the, come on. Oh, Matt just hung his head in chagrin. Sorry. Matt, it's a 5. It makes that go up by 1. Don't just truncate. Don't just, chop it off right there. You always look at the next digit. Oh, I'd take that. Oh, yeah. 42.86 I'm good with. I'd take 42.857. I'd take 42.85701. I'd take if you said 2 and stopped there, I'd say, no, that should be a 3. Just round off properly. Don't truncate. I don't think number 3 is the same question. I think number 3, they're asking me to find T0. I think we said T0. Well, I would move the square root over to the other side by timesing it. Is that okay, Hedrick? You gonna make it? Okay. It's going to be 16 times the square root of 1 minus 0.99 C over C all squared. It's going to be 16 times the square root bracket 1 minus 0.99. Oh, the C's cancel. Yay! So I could just square that. So 16 years on the Earth, only 2.26, 2.257, 2.3. I'll go looks like I'm going most of the time to 3 sig figs, I guess. 2.26, let's be consistent in my coloring. 2.26 years. 2.3 years, yes. 2.257 years, yes. Again, half mark for the equation, 1 mark for the numbers, half mark for the answer. And once again, I'm going to argue, I think number 4 is really the same question as number 3. I think I can go like that. It's just that 15 years, so that's going to be different, that's going to be different, that's going to be different, that's going to be different. I'm still pretty sure there's going to be a decimal, though, because none of these work out evenly. Very few of these work out evenly. 15,995. 15,995. 15 square root bracket 1 minus 0.995 squared. We're going faster, so we should notice a bigger time discrepancy. Oh, yeah. Matt, what would you round that off to? I would too. Although I would also accept 1.498. I just wouldn't accept 1.49 because it's going to be 1.5 no matter what. 1.50, sure. And then we turn the page and this one got tough. You're solving for V. You know what? I don't remember the equation. I'm going to have to rederive it. It was this. You'd move that over. You'd divide by that. You'd square both sides. You'd go, it's going to be 1 minus t0 squared over t squared. Boy. I'll do this the long way. And then if you use the shortcut equation, because I did tell you to write it down, you'll get full marks anyways. The long way would look like this. And then you would say, okay, 100 equals 8 all over the square root of that thing. Remember I said you could replace that with a little gamma? Why? Because where is that little gamma right now? Top or bottom of a fraction? You know what? It's dividing the 8. That's the same as having it over on that side. Which actually I think is the equation that... Oh, I can't remember who it was in this class. You know what? It's this equation here. We're getting the t0 by itself. So I'm going to have this. 100 square root of 1 minus v over c all squared equals 8. I think now I'm going to divide by 100, divide by 100. Thankfully, I can do that in my head. 8 divided by 100 is 0.08. So I'm going to end up with the square root of 1 minus v over c all squared equals 0.08. Now, Haley, I'm going to square both sides. Here, that's just going to cancel that. So I'm going to end up with 1 minus v squared over c squared. Hedrick, I also moved the squared into the brackets. Yeah, am I wrong? I have a visitor. Oh, hang on a second. Pause the video. Hang on 1 second. Hang on. So we'll continue on. Where was... Oh, and then that's going to be... that. 0.0064. Whew. Now what? Courtney, I don't like the fact that there's a minus sign right here. How could I make this a plus sign? How could I make this whole thing positive? Folks, what could I do? Yeah, I'm going to plus it to this side. So I'm going to go plus it there. At the same time, I'm going to go minus it there. And again, if you wrote down the velocity equation, you could have jumped right into this. But I guess it's going to be 1 minus 0.0064 equals v squared over c squared. 1 minus 0.0064, 0.9936, sorry. 0.9936 equals v squared over c squared. You know what? I'm going to times by c squared. You with me so far, Matt? It's a lot of steps. Matt, I have a v squared by itself. How do I get rid of a squared? Oh, excellent. You mean I'm going to go like that, and I'm going to go like that. So here we go. V ends up being the square root of that thing, 0.9967. I'm going to go 0.9968 times c, because the square root of c squared is just c. Now, if you stop there, I will give you full marks. It's 99.68% of the speed of light. Or if you then times that by c, which technically you should have done, because this question didn't say leave it as a percentage. And remember, c is 3 times 10 to the 8th. You're going to get, you get 2.99 times 10 to the 8th? 2.2990. Well, I'm going to go times 10 to the 8th meters per second. Or you could have said 99.68% of the speed of light. If you got that, 3 out of 3. Otherwise, blah, blah, blah. Well, I'd give you a half mark probably for writing that. I'd probably give you 1 whole mark if somewhere along the way I saw the 1 minus v over c squared square root equals the 0.08. And what is that? That's 1.5. I'd probably give you a half mark if you got rid of the square root and got the v squared by itself. And I'd probably give you a half mark if I saw that line. But of course, if you got the right answer, oh, and a half mark for the answer, right, Mr. Dewick? Half mark for the answer. But if you use the v, if you use the v equation, you got the same answer. Is that correct? And if you went straight there, that good. You got your 3 out of 3. Whew! Another tough one, solving for v. Okay. Here we go. Oh, my pen has stopped working. We'll do my real quick repair. I think we'll do my real quick repair. Come on, pen. Hey, now we're working again. Look at that. T equals T's. You know what? I'm going to go straight to this one. T0 equals T square root of 1 minus v over c all squared. Because, Courtney, I want the v not to be in the bottom anyways. Is that okay? I'm going to do this one algebraically. If you do that, you get T0 squared over T squared equals 1 minus V squared over C squared. Is that okay? Then we said, I don't like that minus. Plus it to that side, minus that to that side. You're going to get V squared over C squared equals 1 minus T0 squared over T squared. You're going to get V over C equals the square root of 1 minus T0 squared over T squared. V over what? V over C. How can I move that C over? Times it. There. That's what we put on our formula sheet, yes? Okay. There's the rederivation, just because I'm a nerd, to remind myself that I could do it. Now we plug and chug. Speed is going to be, 3 times 10 to the 8th. Square root of 1 minus T0. T0. T0 is the time on the spaceship. 20. All over, squared? All over 1,000 squared. Okay, I can get this. Do you get 2.9994? By the way, I don't really want to round off, because if I round off to 3, I'm saying we are going the speed of light. If you did round off to 3, I won't take marks off. I didn't realize you had to be going this fast. But it's going to be 2.9994. 2.9994. Did I hear a phone go off? Did I? Was Siri? Was it you? Are you serious? No? Well, thank you. That'll work out great next class. Or if you made it, by the way, what percentage of light is that, Alex? Just like if you get 30 out of 40 on a test, you go 30 divided by 40 times 100. If you're going 2.9994 times 10 to the 8th out of 3 times 10 to the 8th, you divide, and then times 100. Holy smokes. 99.98% of the speed of light. Is that okay? How would I do the mark breakdown for that? Ugh, I don't know. Let's see. 1, 2, 3, 4, 5. Oh, this works out great. Half, 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 half. There's 3 marks. I don't know. If you're not sure, show me. Can you give yourself a lovely score out of, count 'em, 14, please? Last class, if you want to get out lesson 3, if you don't have it already, we asked this question. Alex, we said, get this later, because I'm going to go really fast, and I'd rather have you just pay attention. We asked, why don't we notice relativity in our everyday lives? For what it's worth, we called this funky thing here the Lorentz Factor. It's often symbolized by a gamma. And Alex, we said, this is what determines how big that time slowing down factor is. And so we quickly tried crunching some numbers. We asked, how much does time slow down for a human being walking? And when I ran the numbers, even on my fancy schmancy really good calculator, all the decimals vanished and I got 1. I said, you know what? For a human being walking compared to you standing still, time is 1 to 1. My calculator, although technically there is a difference, my calculator can't keep track of those decimals. It's so small. If we said even for a race car it wasn't noticeable, even for an SR-71 jet fighter it wasn't noticeable, we said it is slightly noticeable because the Earth moves around the sun pretty fast. The sun has time moving slightly slower than us. 1 second for us is 1.08 zeros and a 5 seconds on the sun, which is good. It means the sun will last slightly longer, which we kind of want, because when it goes, we're dead. Then we said, okay, the Earth moves around the galaxy. We asked, is there a time distortion? Yeah, but really, you start to notice it when you start to get speeds in the 10 to the 8th range. Because, Megan, the speed of light, that was a long blink. You with me, Megan? The speed of light is 3 times 10 to the 8th. So when you get like 2.5 times 10 to the 8th, 2.6 times 2.9 times 10 to the 8th, that's when you notice it. By the way, I said for all of these years, but you could just as easily say seconds. So the protons at Triumph, 1 second for them is 1.5 of our seconds because we were at rest relative to them. Or the muons at CERN, 19.4 seconds for them, or since they decay really fast, 19.4 milliseconds for them. Sorry, 1 millisecond for them is 19.4 milliseconds for us. And then we really noticed it with the electrons at the at the Stanford Linear Accelerator. And then it got weird. We said it turns out not only does time get bigger, slow down, Length gets shorter, but there was a problem. Maite, here was the problem. In this equation, L0 is the standing still object. In the time equation, L0 was the moving object. By the way, why is that? This gives you an idea of how Einstein's brain thought. He actually said, no. In the time equation, you're inside the spaceship. Relative to you, you are standing still. It's the universe that's moving away from you. Thank you very much. So it gives you a kind of an idea of how his brain, how he really divided things up and thought about this very, very deeply. But for the way we're doing it, Ryan, you'll have to remember for the length equation, here's what I said. What letter does that look like, Ryan? The original length goes there. Or the other thing I said is the length at speed 0 at rest goes there. Oh, and the gamma factor, Courtney, isn't on the bottom this time. It was tucked beside. But we found that in the direction that you travel, lengths contract. Lengths contract. In fact, really what you would notice would be, will this work, Mr. Dewick? Let's see. I think it will. If you were traveling fast, if you were standing still and an object that was traveling really fast went past you, this is what you would notice. The widths, the heights wouldn't contract. Only the direction of travel would be contracted. So it would look like, and the faster it went, the more you would appear to see something like that. Oh, and what's the relationship? We went back to the beginning, really? Okay. This equation here. We then did a few examples. We noticed that whether you did it the long way or the short way, I went back to that Proxima Centauri star example, and we said, yeah, it turns out if you're moving at relativistic speeds, if you're moving near the speed of light, you will measure space to be shorter. And then I think I got really high-tech and I said that, so for a photon, there's no such thing as distance. Every photon that's ever existed has been everywhere in the universe at once. Ooh. Oh, it gets weirder. So we said pause here. Finish quiz, lesson 2. And you need to get your formula sheet out because I screwed up. I totally forgot to put this one on your formula sheet. So we'll add it in just a second. But it gets even stranger. Einstein also showed us, Courtney, that as objects speed up, there's an increase in mass. What? Yeah. Matter is being created. And this is governed by this equation here, and I forgot to put this equation on your formula sheet. So you want to add this equation on your formula sheet. I'm going to make it really, really big so you can see it easily. On your formula sheet, in the relativity section, you want to add m equals m0, square root of 1 minus 4 squared over c squared. Or if you're really clever, you could write because it's that gamma, that Lorentz factor. In fact, I think that's what I have next in the notes. I said this can also be written using the Lorentz factor. Oh, you know what? Let's just cleverly do this.
Yeah.
M equals m0. Y'all got it okay? Where m0 equals original mass, m equals mass of moving object. So again, just like with length, m0 is not the object that's moving, m0 is original. So, suppose an object had a mass of 10 kilograms while at rest. What would its mass be if it was traveling at a speed of 2.5 times 10 to the 8th meters per second? So m0 is 10. We want m, which is going to equal m0 all over the square root of 1 minus v over c squared. which is 10 all over. Connor, did I give you the speed as a percentage of light, or did I give you the speed in meters per second in 4a? So this time the c's won't cancel. I'll actually have to type in a 3 times 10 to the 8th for the letter c. It's going to be big square root 1 minus 2.5 times 10 to the 8th all over 3 times 10 to the 8th all squared. Is that okay, Amanda? I'm going to, because this one's a bit yuckier, I'm going to do this one the long way. So I'm going to go 2.5 times 10 to the 8th divided by 3 times 10 to the 8th squared. 1 minus that. Yeah, hopefully you have your calculators out. Square root of that. 10 divided by that. What would 10 kilograms be if it was traveling at 18.1 kilograms? Is that okay? What about 98% of the speed of light? Well, m equals m0 all over the square root of 1 minus v over c all squared. It's going to be 10. Oh, John, did they give me the speed of light this time as a percentage of the speed of light? Yep. Yay, the c's will cancel. Square root of 1 minus 0.98 c over c squared. C's cancel. I think, Ryan, this one, I'll try typing it in one fell swoop. It's going to be 10 divided by square root bracket 1 minus, times, Mr. Dewitt, minus 0.98 squared. What would the mass of 10 kilograms increase to at 98% of the speed of light? 50 point. Matt, what would I round this off to, a 2 or a 3? Good. As you go faster, Matt, what seems to be happening to the mass of our object? Is it easier to move lighter objects or heavier objects? So the faster you go, the tougher it is to get you to speed up anymore. This is another reason why the speed of light is a cosmic speed limit. The faster you go, the heavier the object that you're trying to move becomes. And now you need even more energy to get it to speed up the next little tiny bit. In fact, you know what? 98%. Let's up it by only 1%. 99%. Okay. It's going to be 10 all over the square root of 1 minus 0.99 c over c all squared. And yes, Sheldon, the c's will cancel. In fact, I think I can just go backspace and change the 8 to a 9 just to get 1% closer. Picked up extra mass. 70.9 kilos. Here's what the Large Hadron Collider can do with protons. The Large Hadron Collider can get them going that fast, or if you want to put it in numbers, only 2.7 meters per second slower than the speed of light. And you're going to see why we can accelerate protons. Lots of mass or not much mass? No, but although for a subatomic particle, Connor, protons are heavy, we can get electrons going pretty fast, because electrons, compared to a proton, they weigh 10 to the 31 times less. But, okay. Let's see if we can get 10 kilograms going this fast. What would it be? All right. One, two, three, 4, 5, 6, 7, 8 nines, and then a 1. 1, 2, 3, 4, 5, 6, 7, 8 nines, and then a 1. And there would be a C there. There would be a C there, all squared. Lydia, do the C's cancel? Yes, they do. Okay, I'm kind of curious here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8 nines, and then a 1 squared. What would 10 kilograms weigh if you got it to that speed? 74,535.6 kilograms. So mass increases. Length decreases in the direction of travel. Time slows down. I guess you can say since it slows down, time gets bigger. Okay. By the way, what would the mass approach if you were approaching the speed of light? No. This is the problem. Okay. Yeah, infinity. The closer you get to light, the bigger the... Even to get a proton up to the speed of light, you'd end up trying to move an infinite mass. So here's my question. Do photons move at the speed of light? Yes? So how much mass do photons have? No, because if they did, they couldn't move at the speed of light. How much mass must they have? None. Ah, yeah, photons don't have mass. One of the reasons that they're so special, one of the reasons that they can move at the speed of light. No mass. Okay. I had already assigned, I said you could handle 1 through 8. You can now also handle number 9. Number 9 is just conceptual. Number 10 is when you're starting to calculate what happens to mass. Number 11, I haven't done finding V. See if you can figure out how to find V in this equation. I'm going to give you a hint. You'll notice that this equation here looks just like your time one, except wherever there's a T, here you have a M. So you should be able to take your velocity equation for time and just morph it into a mass. And you might even want to add that to your formula sheet. I don't know. It's up to you. So I deliberately didn't do that. I'm curious if you can figure it out. And then 12 is good. 13 is good. 14 is good. 15. I think I'm going to be assigning all of these. Ooh, Starship Enterprise? Absolutely. But there's a typo. The answer to number 6, let me make this much bigger. So on your sheet, I did number 6 totally wrong. In fact, I think it was it Connor? You pointed this one out? So Connor, did I give you your candy? For finding a mystery? I owe you a candy. That there is the correct answer to number 6, not the one that's on your sheet. I do have a handwritten showing all my steps answer key for this. I will post it online. I haven't printed up any copies. I'm going to do that in just a couple of seconds, but I got a short video to show you first.